So my project was about OCR handwritten text summary. I deployed it using Google Cloud Run. So while it loads, I think I should show the code. Um, okay, just for the backend, I used FastAPI and to serve frontend, I use Jinja 2 templates. For about OCR part, I used two models, Easy OCR and TR OCR. Um, the TR OCR is from Microsoft. Why I use two models? Because main function of OCR will be performed by TR-OCR, but the drawback is that TR-OCR can accept only one line of text. So here comes the easy OCR. Uh, it will give us uh, the location or coordinates of the text, and we will convert them into one line, and so that TR OCR could read them as it can. And for summary part, I used BART tokenizer or BART. So like they working structure is pretty similar because they both use encoder and decoder transformers, but in TR-OCR it will as encoder take in image input. In BART it takes as text. So okay, let's uh, show some examples. For example, here I have clean writing. uh, it's actually not was handwriting, just it is another AI just uh, which wrote the I think I need to show just another AI just which tried to mm, write as human. So yeah, it shows like pretty good accuracy in here. Okay, well, let me continue because this will take some time. Okay, here's the main function. It takes from frontend image and checkbox, which is pre-processing checkbox if the image is really, for example, noisy or something. For example, I will show example with this image where it has grid lines, and then it will be hard to OCR to read it. So it will apply the preprocessing to minimize the grid lines and maximize the text part. Okay, here, like, if I'll talk about only main parts, like it's that preprocessing step. It's if it is true, it goes to the preprocessing function, and if not, it just converts it to OpenCV readable array, just NP array. And okay, here I save the preview image, which I will show here. For example, here it shows the preview of the image, and then here we have the summary. It's about 99% I think accurate. Also here I have the extracted text that shows in the console. uh, yeah, so let me choose another image with those grid lines and process it. Okay, let us continue. Here our ready to go image goes to the OCR part, and this function is located here. Pillow image, this is for that easy OCR to find the text coordinates. It returns as bounding boxes text and the confidence level percentage. So also here it has thresholds for, so like if it is not so confident and it is below 30%, we will skip this text part. If it is sure that it's more than 30% sure that it is text, we will have the xy coordinates, then crop the image from original, and uh, here we go to the next function, which is the tr OCR part, which is real OCR part. And okay, here we have the uh, image channel and image channel. To ensure the image channel, we have the right image channels. Okay, just here we have the processor just for TR/OCR to pre-process the images, like normalizing, scaling, transformations. It will return as PyTorch tensor. Here we have the encoding part. It will take those PyTorch tensors and return us token IDs. Here, so like it reads and returns the tokens. Here we have the decoder part, which will take these tokens and convert it to human readable text. Skip special tokens means that like it will skip the tokens such as padding or start or end of sentence. Returns the clean text. Mm. And we have recognized lines that will save the text and the y coordinate of this text. Y coordinate is just for us to, like, if it found this text and this text, saving y coordinate helps us to sort them after, because easy OCR, like it could take this and this and this, like it could make it randomly, and saving also y coordinates helps us to sort them, and based on this sorting we'll have the uh, structured text. Okay, we have this extracted text. Then after we have the extracted text, here comes the summarization logic. First, it counts the words, how many words in the text, and it calculates the parameter which it will use in the encoder part here. As function, it is just like, okay, as function it's just like this. For example, what it means that x is a word count, and if it has about 200 words, it will roughly generate about, I don't know, it's I think it is about 75 or tokens. So like to summarize, it means that compressing tokens into fewer size. So here, first of all, we tokenize this text as in TR-OCR returns PyTorch tensor, but we set max length and the truncation if it exceeds a max length. Also, after it will encode this token IDs will go here, and we set the max length and the minimum length as I explained, and it takes those token IDs and compresses it. It was trained on some emails or mails and with long text mails and the human written summaries. So it will try to summarize, compress these tokens into smaller size, and here we have the length penalty. It's the coefficient how long the text should be, and if it is 1, it will generate a minimum amount of tokens. And this also uses beam search with 2 beams. Here we have this encoded tokens, which is just like compressed, and here we have the decoder part just converts those tokens into human readable text, just like before. And as a result, we have a summary. It sends them into front-end part, the summary, the extracted text, and the preview image. Okay, let us continue here, and as I showed before, here is the original image. Like it has some lighting imbalance and grid lines. So we can see here that the lighting imbalance disappears. It is thresholded and binarized into 2 colors. It's more convenient it's more comfortable to model to read it from this. And the summary, we have some text, but you can see that it's not so accurate. Like here we have the extracted text. Okay, let me show another example without pre-processing. So as I said, I deployed it in Google Cloud Services. Yeah, is 16 gigabytes of memory limit and CPU 4. I used CPU for just like to reduce costs at the result, and you have the our result, the image without pre-processing, and the summary, which is we start. So it's some text and it has some accuracy, but you can't tell that it's not so accurate. Here we have the original text. 3, 4, 5, 7, 8, 9, 10, 11, 13. Here we have also 13 too. Yeah, I think summarization and OCR parts are not so accurate. But here, that's all. You can choose here images. For example, I can show this image, and I think I will finish after this image. I can show the pre-processing step. So as I said, it's thresholds and removes horizontal and vertical lines using morphological operations, and applies the noising, resizing, and sharpening the image a little bit, and we have as a result mm, two color image to read. So you can see the summary, and here's the extracted text. Okay, I think that's all.